the most distant human-made object in the universe, far beyond what any of our ancestors ever dreamed possible, is NASA's Voyager 1 spacecraft. This extraordinary machine, which has ventured so far into the cosmos that it has crossed the threshold into interstellar space, is a testament to the brilliance of human ambition and ingenuity. Imagine this, a spacecraft that was launched 45 years ago, still active, still exploring vast and uncharted territories that no one thought it could reach, well past its original planned lifespan. This is the incredible, awe-inspiring reality of a NASA mission that has redefined what we thought was possible in space exploration. But what makes Voyager 1 even more remarkable, beyond its journey, is the technology it uses. It's sending data back to Earth, data that has traveled millions of miles, using equipment that's older than a cassette player, technology considered ancient by today's standards. But the story doesn't end there. Voyager 1, launched in 1977, recently made a groundbreaking discovery that has sent shockwaves through the scientific community, capturing the attention of people across the globe. What could this extraordinary find be, lying so far away in the reaches of Phase B, and what might it mean for life on Earth? The narrative of Voyager's voyage ties back to a pivotal moment in history, a key moment that would alter the trajectory of space exploration. It was thanks to the brilliant mind of Gary Flandreau, a visionary at NASA's Jet Propulsion Laboratory, that the ideal route for the spacecraft was charted. Flandreau, using nothing more than a pencil and the engineering tools of the 21st century, made a stunning discovery in the late 1970s and early 1980s. The four giant planets of our solar system, Jupiter, Saturn, Uranus, and Neptune, would align in a unique cosmic configuration, creating what could only be described as a celestial necklace stretching from Earth. This cosmic alignment, a rare phenomenon that occurs only once every 176 years, would allow a spacecraft passing close to each of these planets to gain speed through their gravity, as though being pulled by an invisible cosmic rope. This would result in a reduction in travel time from Earth to Neptune, a journey that would have typically taken 30 years, down to just 12 years. NASA, seizing the once-in-a-lifetime opportunity, acted swiftly. In the summer of 1977, just 15 days apart, they launched two identical spacecraft, Voyager 1 and Voyager 2, setting them on a course to take full advantage of this extraordinary cosmic alignment. At the time, no one could have known that these twin explorers would go on to break all records in the history of space missions. More than 45 years later, the Voyager 1 and Voyager 2 spacecraft are still operational, still transmitting valuable information back to Earth daily, shedding light on the outermost reaches of our solar system. They have traveled farther than any spacecraft in history, venturing far beyond what anyone had ever imagined. What is even more remarkable is that these probes were originally designed for a mission that would last just 4 years. Yet, these interstellar pioneers have continuously surprised us, exceeding all expectations. From the start of their epic journeys, they have delivered some of the most incredible close-up images of distant worlds. The moons of Jupiter and Saturn, once shrouded in mystery, were revealed in unprecedented detail, showing us worlds more active and dynamic than we ever thought possible. The discovery of active volcanoes and vast ice fields forever changed our understanding of these distant corners of the solar system. Voyager 2, in particular, etched its name into the annals of space exploration as the first spacecraft to approach Uranus in 1986, followed by Neptune in 1989. In doing so, it became the only probe to exist between these two distant planets. Its journey continues to surprise scientists with astonishing findings from unexplored territories, more than 14 billion kilometers away from Earth. These diminutive, beetle-sized spacecraft have defied all odds, continuing to expand the boundaries of our knowledge. Their journey began with a gravity assist maneuver around Venus, a maneuver never before attempted by any spacecraft, which set them on a path to Mercury, making them true pioneers of space travel. The journey to Jupiter alone took the spacecraft 10 times the distance from Earth to Mercury, forcing them to pass through the dangerous asteroid belt. This was a feat that had only been previously tackled by Pioneer 10 and 11 probes. Yet, even with these early accomplishments, the challenges were far from over. Voyager's systems were equipped with only 69 kilobytes of memory, less than a fraction of the capacity of a modern smartphone. The onboard computers had to rely on their own intelligence to navigate and manage the complexities of this extraordinary journey. Data collected by the spacecraft's instruments was stored on magnetic tape recorders before being transmitted to Earth using a transmitter that only consumed 23 watts of power, roughly the same amount of power as a simple light bulb. This limited power output posed significant challenges for communication. The probes were equipped with 12-foot diameter satellite dishes to facilitate communication, using light-speed radio waves to send and receive messages across the vast stretches of space. As the distance between Voyager and Earth grew, so did the challenges. Each day, the spacecraft moved further away, advancing by 3 or 4 light seconds daily. For example, by the time Voyager 2's signals were received on Earth, they took more than 18 hours to reach their destination. The increasing background noise from radios, televisions, cell phones, and other electronic devices made it progressively harder to pick up the faint signals from the spacecraft. Yet despite these overwhelming obstacles, the Voyager probes continue to astonish astronomers with their unexpected discoveries in the interstellar void. Their journey has not only rewritten our understanding of the cosmos, but has also altered our perception of the unknown. Beyond the boundary of our solar system lies the enigmatic Oort cloud, a vast collection of comet-like objects held together by the sun's gravity, stretching all the way to the nearest star. Although the Voyager spacecraft are still slowly moving toward this distant realm, their entry into interstellar space began when they crossed the heliopause, the boundary between our solar system and interstellar space. Initially, this boundary was estimated to be about 50 astronomical units from Earth, and so it was decided to continue funding the mission as it approached this milestone. Yet, when the spacecraft crossed this threshold, the expected changes in the environment did not materialize as anticipated. The passage into interstellar space was expected to result in an abrupt increase in the number of cosmic rays, high-energy particles traveling at nearly the speed of light, ejected by supernovae and other cosmic phenomena. However, the expected surge of these rays did not occur. Most of the high-energy rays are deflected by the magnetic shield generated by the heliosphere, which protects our solar system from external threats. The Voyager mission team also closely monitored any changes in the prevailing magnetic field as the spacecraft entered the interstellar medium, an environment composed of ionized gases and influenced by nearby stars. The interstellar magnetic field was expected to be oriented differently compared to the magnetic field of the heliosphere. However, the Voyager probes did not detect any significant changes in the magnetic field. On August 25, 2012, Voyager 1 crossed the heliopause and transmitted fascinating data confirming the expected increase in plasma density. Yet, remarkably, there was no evidence of a change in the magnetic fields. This unexpected finding left scientists baffled, as they had anticipated that transitioning from a region dominated by the solar magnetic field to one influenced by other stars would result in a noticeable variation in the direction of the magnetic field. Despite this surprise, the Voyager spacecraft continued to send data, pushing the limits of what we understand about our universe. They have become a symbol of humanity's relentless pursuit of knowledge, a beacon of exploration that has charted a course into the unknown, far beyond where any spacecraft has gone before. The journey of the Voyager probes is not just a triumph of engineering and science, it is a journey that has expanded the very horizons of human understanding. As these spacecraft drift further into the interstellar void, they continue to provide us with insights into the cosmos, transforming our knowledge of space, time, and the very nature of the universe itself. Their discoveries have reshaped our view of the universe, inspiring generations of scientists, astronomers, and dreamers to look beyond the stars, to reach for the impossible, and to explore the unknown. As they continue their silent journey through the vast emptiness of space, they remind us of the incredible potential of human curiosity and the unyielding drive to discover what lies beyond the veil of our understanding.